Hi, everyone. This is Arnab Chatterjee from Digital Transitions, and today I'm joined by Don Williams of Image Science Associates, or ISA. Don, do you want to tell me a little bit about ISA and what you're going to be talking about today?
Sure. We've been quite busy during this COVID environment, but this has given us time to concentrate on new and I think easier to use tools uh, and some upgraded possibilities for targets. So what ISA is in the past, we do uh, color, tone, we do imaging performance measurements and resources to measure those for digital imaging in the cultural heritage environment. Okay, I know there's a lot there, but uh, the in the past the approach we've always taken was okay. Our mantra, by the way, was if you can't measure it, you can't manage it. So we've tried to provide tools to help users manage their digital imaging performance with respect to standardized digital imaging protocols, specifically what is resolution, what is color, and yes, there are actual ISO metrics for doing that. Really, there are. And when we've gone out to the users in the past, um, the maybe a universal comment has always been, "Oh, that's great. So I'm good here, but I'm bad here." Yeah. We say, "Well, you could use some improvement in these other areas." And of course, they would say, "Well, how do I fix it?" I said, "Oh, well, with respect to hardware, we would always like lenses. We'd say, hey, you might want a different lens, try this or that." But on some issues like color and tone and gamma, these terms you hear, there are so many user options in many of the camera tools that those are not universally uh, standardized. So we say, okay, we will help you fix those. So people have said, how do I fix it? So in terms of this doctor metaphor, we say, oh, that's right. We've just told them what's wrong and not how to fix it. So in the new version of the software, we've enabled tools and embedded tools to allow users to now do that fixing a little bit better. And frankly, we've in the new versions of software and targeting tried to make it easier for users to go through the process of measurement.
Excellent. So I understand today that we're going to be looking at the newest version, which is still in beta, of the GoldenThread software, which is GoldenThread NXT. And you've also developed a new target, which is the FADGI, Metamorfoze, and of course now ISO compliant target that we're going to be seeing in the demo to give us the readings and the profiling and whatnot that we're going to be seeing in the software. Is that right?
That's correct. Yes, uh, our initial device target, many of you are familiar with it, 7 by 10 inch item it was a really good start to get users involved with this process. But as we've moved along over the last 10 years, we've said, okay, there's a new ISO standard out there, 19264, that combines Metamorphose and FADGI criteria. And also the targeting features on there is to measure these different imaging performance metrics. So that's what we've done with the new target. It's fully 19264 compatible. And it allows you to do really good color profiling also with 168 patches. Correct.
Excellent. So why don't we jump right into the demo and let's see what it's all about.
Okay, here we go.
So, Don, the first thing that you mentioned that's different with the new version of Golden Thread is that it's a lot more user friendly. There's a lot more automated stuff going on in terms of detecting targets, PPI, color profiles, that sort of thing, just to sort of simplify the user experience. Do you want
Mm-hmm.
to run us through that to start off?
Sure. Let me start here with as they say, the landing or home page for Golden Thread. It looks similar to the past, but we under the hood there are considerable differences. Uh, I have set as my default target this new FADGI 19264 target. Okay, so this whole target selection area is similar to the past. But of course, we have other ones that we support. The NGTV2, the color checker SG, the 24 patch, and even the dice and object level targets. Okay, so that's similar. I'm going to jump over to number 3. That's the easy one. You say, okay, where's the image? Show me the image. But the major changes are under this number 2 area. In the past, users would have to say, okay, I'm going to do an analysis, but you have to tell me a little. Do you want me to do what color space, what PPI, what star level, or the FADGI star levels? I understood, because I've used it, that, oh boy, that's a lot of jumping around. Can't we automate that more? And
Hmm.
also make the number 2 area a little bit more FADGI friendly, in the sense of the way FADGI has articulated different categories of performance is through different types of content. So you can see, if you go to the FADGI document, it says, oh, are you doing volumes rare, general, etc. Today, we're just going to concentrate on unbound general. By the way, most of the limits, the criteria for each of these project categories in FADGI are very similar. There are a few differences based on content type that might be considered a little bit more fragile, and so we have to adopt the limits differently. But they're generally pretty much the same in terms of star levels. So what you'll
Right.
see here is that we've eliminated all the options for the user to select by doing this, let me say, autonomously. So for instance, color spaces, we say, well, almost all files coming in from users have some type of embedded color profile. So we say, and they typically are ISO categorized ones. Adobe RGB 98, sRGB, you can see. And by the way, you can see now we've allowed the user to dynamically swap between those different color spaces now. So that if you say, oh, I'm in the wrong color space, I really meant to be 98. We say, in the past, you would actually have to go in and re-ingest the image and do it over again. So, well, the image is there. Let's just archive all that data and interpret it with respect to all these other supported color profiles. Now, keep this in mind. At the end, you'll see how we can actually generate custom color profiles from this data.
Hmm.
So that's the simplicity. And by the way, most images coming in already have embedded the PPI in the header. So that leaves us with the categories 4, 3, 2, 1 stars. So what we have done is now present all those star levels in context rather than just a singular one. You'll see what we mean when we go through the demonstration. How does that sound, Arnab?
Sounds excellent. I think when folks go in and look at the FADGI document, each different material type has a table with the stars, 1 through 4, outlined in terms of what the criteria are to meet those levels. And so it sounds like what you've done is, rather than having them choose one row or column from each one of those, you've just brought in the entire table, and now you show them, where in that table you fall, sort of per criteria, or per
Yeah,
unit, right?
it's largely, yeah, think of it as it's context based. We provide some context relative to these. So for instance, in the past you'd get a fail and you say, well, how much did I fail? And we
Right.
say, well, here, we're going to do that graphically so we can get a sense of, oh, I was just out by a smidge, or whoa, that's a lot. So uh, we've tried to make all that easier uh, to see and to interpret.
Excellent. Do you want to show us an image,
Sure.
and once we
Yeah,
dive
so
right
I'll
into it?
start out and I'm going to select an image. This is one we got from some folks in Washington. It brings in the image. Notice it automatically detects the color profile. And we've taken very much a Photoshop-like approach here. Say, oh, is this the one you want? If you don't want to see it anymore, just turn it off. I'm going to turn it off because mostly we'll say, yeah, if the profile is in there, there must be some reason they put it in there. So we say yes. So it'll bring in the image. This is the new FADGI 19264 target. You see, it has a whole lot more colors, 168. And I'll just start out by saying we're going to crop and identify. This is all autonomous. It'll identify the target, uh, look for the regions of interest. And what I'll do here, this gets a little busy because there's a lot of regions of interest based on the kinds of metrics we're looking to evaluate. So I'm just going to say, okay, here's all the colors. And you can turn these on or off as you see fit. And by the way, there's a rollover magnify tool too, if you want to see that. You can click up, click down, see any, sometimes if there's blemishes or marks on the target, you'd like to see that. So I'm going to turn this off for
Very
now.
handy. Now, Don,
Yes,
just
yeah,
quickly, I know you mentioned automatically detecting PPI. Do
yes,
we do that in this case? And if so, how does that work?
yes. In fact, you'll see that um, because, and this is one of those obvious things where you say, well, okay, it's 300 DPI. And we very frequently find that users, software will boilerplate stamp resolutions into the header of the file. So for instance, I think in this one, you'll find out that it's 300 DPI. And we extract that and we say, okay, we are going to test against 300 DPI because that's what the embedded data said it was. You'll
Got
find
it.
out that it was actually some, when we measure it, it's really 100, 350 something DPI.
Got
You
it.
say, okay. So what this means, if you're digitizing stuff, is that if in the future people go back and say, oh, this is the size of this based on the resolution, they're going to get a wrong impression of what the actual original size was based on that embedded data. So this is what we test against.
Got it. Now,
Uh,
if that information is not embedded in there, what's the process for entering that? Would it ask me once I imported it?
uh, the the process for that is that, well, the user should have to somehow change that. Or what we are currently working on now is a tool to remediate those issues, is to say, oh, this is really 354 DPI. Well, here, give me that image, and we'll just re-embed the right DPI in there. So it's really this is where one of our other software tools, Golden Touch, performs. It actually looks at that data and says, ah, wrong DPI. Here, we'll correct that for you in a post-processing approach.
I think that's smart, especially because if you're doing it in an archival environment,
Mm-hmm.
even if you evaluate it in a Golden Thread report and find out, okay, it's 354, if you leave the file as 300, then you're essentially losing that information if you don't have the report attached to it. So actually updating the information there is a smart way to go about it, I think.
Right.
Um,
So,
Anyways, go ahead, go
yeah.
ahead.
So I'll just continue. I'll be very brief here. And here's, you can click all these off. There's where we evaluate the real optical resolution with these SFRs, spatial frequency response. We have in the new target these rastering banding uh, detection stripes, white, gray, and black, to see if there's any kind of striping that goes on, especially with linear array scanners. And finally, we do in the new target, we measure uniformity over that entire target area. Now, clearly there are areas that we cannot measure because there's content there, but you can see we've provided interstitial areas between the patches. And we're very happy with the uniformity of the specific target. So with all that in mind, we'll just go back to all groups and we'll just say run. And what it'll do, it'll start running. And right now it's going through the process of extracting all that data And at the bottom, there's a little bit of a flashing status bar on what's going on. So it's processing the data, going through the algorithms to evaluate and measure color errors, tone response, resolution, things like that. So in this specific target, there's a lot of data there. Processing is complete. So
Excellent.
we go, by the way, the user can select which of these tabs up here they'd like to go to as a default. For this
Hmm.
demonstration, we've done it just for the summary tab. And the reason I selected this particular one is because this is most consistent with the past Golden Thread.
Could
And
you
what
maximize
is
it
that?
just so we see it as large as possible?
Oh, yeah, sure.
Thanks.
That's not particularly large, but we'll keep it there. Let's see.
Okay.
Yeah.
Yeah,
Okay.
it's about the same. Okay.
Okay. So this is what we've done. We've always in the past evaluated in terms, all the data in terms of what we call a camera model, the way the camera sees things. RGB, that's what the camera sees. And so we've evaluated all of these with respect to this color working space that was embedded. And we said, okay, here's the context for tone scale. 48% of them were 4-star, 31% were 3-star, et cetera, et cetera. And then some of these were way out, was 1-star. Some users have said, well, please don't show, that's TMI, too much information. Can you sort of beat that down a little? They say, I just want to see if I've passed 3-star. So we said, okay, just click on the 3 and it'll say green, good, red, not so good. And this is how we now allow the user to see everything just with respect to a single star level. But if you're not, you can unclick it and it brings it back to where it is.
Very cool.
What we're now trying to do with FADGI, especially, is to evaluate everything with respect to the colorimetric world. So RGB is the camera world, the way the camera sees things. And we're saying, well, yeah, but there's LABs, those are colors, and that's how the human sees things. And that's really where 19264 comes to play. We say, yeah, we really need to normalize to the human perspective, the way the human sees things. And so now you can see we can toggle back and forth between colorimetric
Hmm.
and RGB modalities in the new version of software. And by the way, if you go to the FADGI document, you'll see that these dual criteria are embedded in that. They'll say, okay, do you want to look at colorimetric or do you want to look at RGB? We are really trying to move away from specifying in terms of RGB because it gets, frankly, a little too chaotic and not normalized. So
Absolutely.
that's how things look right now. Um, you say, getting back to our introductory comments, we said, well, wait a minute. Uh, okay, so you've reported things are good or bad. Yes, we have. Can you show me a little bit more context? Let's say with respect to tone scale. So this is one of the items that we're trying to integrate all FADGI star levels in one look. We've done it here, but I'm going to go back to, just as an example, tone scale. And this is what we've done here now, is you can see, oh, if we're evaluating white balance, we've said, oh, so green is 4-star, blue is 3-star, this yellow orange is 2-star. And by the way, the user can select your favorite colors in here. But what we've done, yes, so you can be a little bit more artistic. We've done the top 3 are how we have done this in the past, RGBs, the way the camera
Right.
sees. But by interpreting these count values through this color profile, we turn those into LABs or colorimetrics. So
Yep.
all of these top 3 via this filter up here turns us into colorimetric or the bottom one. So now we've demonstrated and shown all of the content with respect to all FADGI star levels. Um, So you can do this with all the aim curves. So for instance, this is the RGB world for this particular color space. If you want to now quickly see what that looks like colorimetrically, you say, oh, so the dashed green line is where we want to be. That's right. And the black line is where we are. Yes, so you can see we did pretty well up until the mid grays, and then things went a little off kilter. So that's how
Now,
that's
as
done.
you, yeah, and that's great. I think in the past you had to say, what does it look like compared to 3 star? And if it didn't look so good, then you had to go and say, well, what does it look like compared to 2 star? Rerun the whole thing.
Yeah,
And so
exactly.
now showing it in terms of the entire category with these corridors, that's really handy because you only have to run it once, and it gives you a really nice visual uh, interpretation of, okay, we're good here. Okay, we're not so good here. We need to adjust our image in the lower part of that tone scale. Now, one of the
Right.
things that you mentioned in the introduction, though, was working kind of like a doctor and saying, okay, these are your symptoms, and patient says, okay, great, can you fix it, right? Can you fix me? Um, so I understand that in this new version of GoldenThread, you actually have introduced some tools to remediate some of these errors as they come in.
That's right, Arnab. And I'm glad you said some of them. So, for instance, there are some things that we can't fix,
Mhm.
um, regrettably. Is so, for instance, if you're out of focus, there's not a whole lot we can do. Uh,
Right.
Sometimes you just, or if you have a bad lens, some of this is really hardware related as opposed to image processing related. So we say, okay, what things can we fix? And we, through a lot of experimentation, we have noted that, well, a lot of the tone scale, color error, white balance areas can really be easily corrected with custom color profiles.
Hmm.
And so we support right now three of them. The one we'll be demonstrating is the Argyle color libraries, but also we're in the process of integrating the commercial versions um, of Basic Color. We still have to do that, but we're close. And SpectraCore. So basically, if you have licenses for those, you'll be able to now call those uh, those color profiling engines. Our thought process was, now wait a minute, we have 168 patches here. You can really create a good color profile from that. And by the way, all of our targets, if we go back here, we detect what the actual colors are for that specific target because we have serialized these. This is a serial number F0052. And so on the install of the software, the NXT software, all of the all of the target serial number data is embedded in that install. So even if you get somebody else's target, you don't have to embed their specific, you don't have to say, so where's your color reference data? We say, that's okay. We have managed all that under the hood. It is not, by the way, we don't go to the cloud for that.
Hmm.
It is all embedded at the install.
Excellent. That was
So,
going to be my next question.
yeah,
And so just to backtrack a little bit, does that mean that every single one of your targets is hand measured spectrally?
that is correct. Now, and even um, we always did this for the device targets. We did this for the naturally the FADGI targets. We never had done it for the object targets until now. So even the object level targets have um, they're all serialized, they're all measured, and our software, this software via OCR tools, will automatically detect that serial number and call up that specific data. So we're really trying to make this easier on using custom measured data. And we've done this, by the way, for the other color targets, like the Color Checker SG, the NGTV2 also. Yeah.
Very cool.
So with that in mind, at this point, we have all the LAB data for this target, and we have all of the RGB data from this analysis. Well, that's all you need for a color profile,
Yeah.
those triad pairs. So what we're going to do, we're going to say, hey, generate a color profile for me from that data. So we're going to click it, and you'll see at the bottom of the screen, it'll give a status update. It'll say running Argyle color profile software.
And you pointed
Let's see.
out that in order to use Basic Color or SpectraCore, you need to have a licensed version of that software on
That's
the
true.
computer. But
Yeah,
Argyle is free, open source library that comes installed with GoldenThread. Is that correct?
that's right. Exactly. And we know if users have their own preferences. So we're going to say, look, choose what you want. If you're comfortable with either SpectraCore or Basic Color, then by all means, we will help you do that. We're not trying to change your behaviors so much that we're imposing on you.
Yeah, but this is a
So
big change in workflow, right? Because now you don't need to switch
mhm,
between multiple pieces of software, reanalyze,
exactly,
shoot at different targets. So not only does the software bring these things together, but the new target allows you to both evaluate device performance and also generate a color profile with a single unit.
exactly. So what I'm going to show you next here is we generated that color profile. And so for those of you familiar with Photoshop, we are basically at this point, we have assigned that color profile to the image coming in. So, uh, so let's see, here is that profile, and we're going to turn it into the colorimetric mode. So that profile has changed uh, the look of the image with regard to the real LAB colors. And you can now see, if you go into colorimetric mode and use that assigned profile, things are looking much better here. Okay.
Yeah,
By the way, you'll see the red here. What's happening there? Remember, these are the things that we can't fix.
right.
Uh, but this was, if we just briefly, if we go to resolution, you'll see we the header said 400, but when we measured it, it was 475.
Mhm.
Nevertheless, this was actually a good scan, except for the metadata population. So,
Right, right.
so
But if we
mhm.
go back and look at what you were showing us with the tone scale and the color response, we've remediated pretty much all of that. So it's now just visually looking at it, it's FADGI 3 compliant in that sense.
In that
Uh,
sense, right.
and just a bit of a tweak, I imagine, going back to the raw file or the TIFF would get you to 4-star in the color registration.
Yeah, exactly. There's probably just a bit of, I don't know what if there was a small horizontal component that was off here. We won't go into that at this time, but we
Sure.
always can in future presentations. Uh, we, I have to admit, we always look forward to users' comments. And one of the comments a user had was, okay, now wait a minute, but I'm just used to RGBs. So if we go back to the RGB world, that is, oh, so you want to think Photoshop, you want to now convert that data into an RGB world. You want to keep the good LAB look, human look, but we want to change the underlying data, the translation of that into another color, more, let's say, a more portable color space. And well, there's four of them. A popular one is Adobe RGB. We
Mm-hmm.
say, okay, so right now, if we looked at that data, we said, well, this is how it performed with respect to Adobe RGB colorimetrically. You say, okay, but I want you to actually change the data to Adobe RGB. You say, oh, we haven't changed the data, we've just changed the look. That's the profile. So what we're going to now do is say, I I want a portable color space. Okay, so with respect to people knowing Photoshop, you now go under the edit, pull down, and say convert to, and that's what we've done here. So now you'll see, say, okay, convert this to Adobe RGB. You can see, okay, that now look at the bottom. We're now converting the data and analyzing the image. Now remember, that operation between assigning and converting, it's not flawless. Is that
Right.
there are losses involved there. So let's now see how we did colorimetrically and uh, with respect to Adobe RGB. So you now we see we've still done very well, and there are always little bits of issues that go on with this, with that conversion. But that's pretty much how we've now started to help remediate issues. By the way, we save these color profiles wherever you would like them. So for instance, if you go under Tools, Settings, Color, it'll say, okay, after we're all done, where would you like me to save that color profile? So if you're on the Mac side, we can say, put it over here. But there's certain color sync folders where all applications tend to look for color profiles. So
Right.
by the way, right here, I'm running on a Mac, but I'm running on Parallels under Windows. So we've been doing this for the last 7 years, and other people have done it very successfully too. So don't let that be an impediment.
Yeah. Yeah. Great. Um, well, thank you, Don. I think that's a great illustration of some of the new features of GoldenThread NXT. From what I understand, it's still under development, but we've got some announcements coming up soon.
Yes.
Hopefully, in conjunction with some DT events. So we're really looking forward to that. Is there anything else you'd like to close out and leave our viewers with today?
No, we always look for customer inputs. We learned a lot from the community. The targets themselves are available, and the software is in beta. So if anybody would like to beta test it, that's fine with me. We're the more users, the better inputs we get. So yeah, that's my final comments for now.
Excellent. Well, thank you so much for joining us, Don, and we look forward to seeing more from you in the future.
Okay, thank you.